Alright, you ready for this? Are y'all ready for this? It's been a week-long hiatus, but I'm back at it again. Wow. Alright. Working with content. Information on using art created in external applications. Importing it into Unreal Engine. And setting it up for use in visualization and interactive applications. Most of the artistic assets that you will use in Unreal Engine are created using external 3D applications such as 3ds Max, Maya, Quicksilver, ZBrush, and others. Below you will find information on the types of assets that are created externally and what tools are available for bringing them into the engine. Asset creation locations. You think I care? If I give a damn? Frankly, my dear, I do not give a damn. Game levels. Material. Written in Unreal Engine. Game levels. Materials, particle systems, syntax sequences, blueprints, scripts, AI navigation meshes, pre-calculated light maps, level lights. Create using external application. Static meshes, skeletal animation, textures, sounds, WAVs, IES light, profiles, NVIDIA, Apex files, APB, and APX. Starting out. ArtistQuickStart. Learn how to get started with Unreal Engine 5. As a content creator. What? The Alembic file format, ABC, is an open computer graphics interchange framework that distills complex animated scenes into non-procedural application-independent center-based geometric results. Unreal Engine 4, even though around 5, enables you to import your Alembic files through the Alembic importer, which gives you the freedom to create complex animations externally and bring them into Unreal Engine 4 and render them in real time. Import Alembic files in a similar manner to several of the other forms of exporting content into Unreal Engine 4. You can also watch the Unreal Engine livestream on application topics, which include the Alembic file importer. Exporting Alembic caches. To export an Alembic cache from Autodesk Maya, from the File menu under Cache and Alembic Cache, and export all to Alembic or selection based on your needs. In the export window under Advanced Options, enable UV Write and Write Face Sets option, then click Export. You will need to enable Write Face Sets if you plan to create materials during import into Unreal Engine 4, as materials are created based on found face set names. Import Alembic files. To import an Alembic file into Unreal Engine 4 inside the content browser, click the import button and point to your ABC file. Whoa. What did UG do? What? Okay. That's random. He's like 17. The Alembic Cache Import Options window will appear where you can define the method options for importing. This window displays the name of the file and location you are importing from.
You will also see checkbox options for the assets within the file that you can choose to include or exclude from the import process. You can also use the top level checkbox to include or exclude all tracks. Currently, Unreal Engine only supports meshes containing 3 or 4-sided polygons. Your Alembic data will fail if you to load if your geometric data contains any polygons with greater than 4 sides. If your geometry is made of NURBS or subdivision surfaces, import as static mesh. During the import process, you can find how to import your content. By default, the Alembic import type is set to static mesh. Importing an Alembic cache as a static mesh will import a single frame specified by frame start value in the sampling section as one or multiple static meshes. The Alembic animation from that frame will be imported as a static mesh asset and without animation. The following settings are also available. Static mesh options. Setting, description, merged meshes. Enable us to merge the static meshes on import. This can cause problems with overlapping UV sets. Propagate matrix transformations. Enable to apply matrix transformations to meshes before merging them. See propagate matrix transformations. Generate light map UVs. Enable to create light map UVs on import. When importing an Alembic file as a static mesh, if your data contains several meshes within it, you can choose merge meshes to create a single static mesh inside Unreal Engine. If you disable this option, each mesh within your Alembic file will be imported into Unreal Engine 4 as an individual static mesh instead. Propagate static matrix transformations. When enabling merge caches, consider whether or not to propagate matrix transformations prior to merging the meshes. This will take the transformation data contained within the Alembic file and propagate it into the meshes upon merging so they can retain their transformed data. Consider the sample scene created below, which we export as an Alembic cache. When we import the file into Unreal Engine 4 as a static mesh with merge assets, merge meshes, propagate matrix transformations, we get the following. Coolio. For merge meshes but unchecked propagate matrix transformations, we get the following. Whoa. Each of the meshes are merged at the 000 origin. World origin. Sampling options. Sampling type per frame. Frame start 0. Frame end 1100. Skip entry frames at start of Alembic sequence. Setting description. Sampling type. This type of sampling formed while importing the animation. Per frame default samples the animation according to the imported data. Per X frames. And I turn this up. I'm not sure what it does. I'm not sure it moves. Oh, this one. Yeah. Okay, hopefully that's louder. Per time step. Samples the animation at given intervals determined by time steps. Frame start. The starting index to start sampling the animation from. Frame end. Ending index to stop sampling the animation at. Skip empty frames at start of Alembic sequence. Skip empty pre-roll frames where there is no geometry and start importing at the frame which contains actual data. Normal calculation options. Setting description, force one smoothing group per object. Enables for smooth normals for each individual object rather than calculating smoothing groups. Hard edge angle threshold. Threshold value that determines whether an angle between two normals should be considered hard. Closer to zero means more smooth. Recompute normals. Enable to force a recomputation of normals in order to generate triangles. Enable to in order to generate triangles when calculating tangents and normals. How normals are calculated. The following is a high-level overview of how normals are calculated based on the import type and how normals are used within the file to be imported. When importing a file that contains normals for all frames, for static meshes geometry cache, the engine uses existing normals. For skeletal meshes, the normals from the first frame determine smoothing groups, which are used to calculate normals for the average frame in all the faces. In morph targets, we do this in all cases. When importing a file that contains normals for only the first frames, for static meshes, if using frame 0, the engine uses existing normals. Otherwise, it calculates smoothing groups and normals for the requested frame. Per geometry cache, the engine calculates smoothing groups and resulting normals for all frames. When importing a file that contains no normals, the engine calculates non-smoothing normals. Non-smoothing normals generate smoothing groups according to the calculated normals and recalculates normals within the smoothing groups. Enabling recompute normals, the path specified above is used for no normals. When importing a skeleton mesh, your animation has a large normal delta. You may run into issues getting correct looking normals. This is a known issue caused by the way morph targets can alter the face and vertex normals. As a workaround, you can bypass this problem by using the experimental skin cache feature. You can enable this feature in project settings using the support compute skin cache. Force all skin meshes to recompute tangents options. This should recompile shaders the next time you start the editor. When you open the skeletal mesh asset, you should be able to enable recompute tangent option for each material or section. How smoothing groups are calculated. If you have hard edges on the meshes you import, you may want to look at the hard-edged angle threshold, how smoothing group calculation is performed.
1, 0.
To calculate smoothing groups, first the vertex and face normals are calculated, which are then used to look at all the faces that connect to a particular face. By calculating the angle between the normals, then determine if an edge is hard or soft, similar to the soft hard edges tool in Maya. Below the image on the left, we would consider a soft edge, while this image on the right a hard edge. And this is because the angle between the two normals in the image on the left is smaller than that of the angle of the two normals on the image on the right. Knowing this, we use a dot product to generate a range from 0 to 1 as a threshold to define when an edge should be hard versus soft. For example, a value closer to 1 would mean that the angle is larger, resulting in a hard edge, while closer to 0 would mean a soft edge. This information is then used to generate groups of normals and share soft edges. For each of these groups, we smooth the normals across the faces, creating smooth faces. Forcing one smoothing group per object makes each individual object completely smooth, all soft edges. Import as geometry cache. Importing a geometry cache creates a new type of animation asset that allows playback of vertex varying sequences. The imported Alembic animation will be played as a flipbook of all frames, and performance will scale with the complexity of your mesh. The geometry cache includes the same sampling and normal calculation settings as the static mesh import option, while adding additional support materials and motion vectors. The method of import has the ability to create materials according to found face set names. This will not work without face sets defined in an external application and exported as part of the Alembic cache. Importing motion vectors is enabled by changing the motion vectors option found in the geometry cache category of the importer. Click the small down arrow at the bottom of the geometry cache section to see these options.
Setting. Description. No motion vectors. No motion vectors will be present in the geometry cache, enabled by default. Choosing this option will result in no motion blur. Import ABC velocities as motion vectors. Import the velocities from the Alembic file. Convert them to motion vectors. Storing the motion vectors on disk will increase the file size. If your geometry cache contains changing topology, number of vertices changes during the animation, make sure to export vertex velocities from your 3D application and use this option. Calculate motion vectors during import. Forces calculation of motion vectors during import. Storing the motion vectors on disk will increase the file size. If your geometry cache does not contain changing topology, the number of vertices changes during the animation. Use this option. Include motion vectors to calculate the vertex velocities of your model and use them to calculate motion blur.
Currently, geometry cache assets do not support an adjacent buffer, which is required for tessellation setup. As a workaround, you can import animation as skeletal mesh with morph targets, which is a more compressed way of importing, as this will support tessellation. Import as skeletal. This method imports its Alembic file as skeletal mesh containing base poses as morph targets and blending between them to achieve the correct animation frame. Importing as a skeletal mesh is the most efficient way to play back an Alembic animation, as long as the vertex count does not change. During import, your animation sequence will be compressed using the principal component analysis (PCA) scheme, in which common poses bases are extracted and weighted to compose the original animation during playback time. When importing as a skeletal mesh, in addition to sample normal calculation and a create materials option, you can also define a percentage or fixed number of bases used to tweak the level of compression. Compression options. Setting description. Merge meshes. Enabled to merge the individual meshes for compression purposes. Bake matrix animation. Enables to bake matrix only animation as vertex animation. Base calculation type. Determines how the final number of bases that are stored as morph targets are calculated. Percentage based. Default determines the number of bases to use with the given percentage. Fixed number sets a fixed number of bases to import. Percentage max number of total bases. generates the given percentage of fixed number of bases as morph targets. This is one of the more important aspects of the level of compression. Entering a low amount of bases compresses the animation more. The fine animation detail may be lost. Conversely, entering a high number of bases results in less compression, retains more animation detail. Minimum number of vertex influence percentage sets the animation minimum percentage of influence vertices required for a morph target to be valid. This setting allows you to determine when a base or morph target is imported based on your defined percentage of influence. For example, if you have a model with 1,000 animations containing insignificant vertex displacement from the origin may cause distortion to the skeletal mesh. You can mitigate this by choosing the no compression option for base calculation type enable merge meshes. Alright, with that I will bid you adieu. That is the end of the Alembic file importer. I think I should probably keep these videos somewhat shorter. The other option is to read until localization, like there's a half hour to send this. Maybe 20 minutes, but still. Like 20, 30. I don't even know, man. It's a lot. So, I mean, I'll still do it, but, like, I don't think I want it in one video. When is it? Yeah. Mine. I would lose a lot of time to compiling and whatnot. ArtistQuickStart. Learn how to get started with Unreal Engine 5 as the content creator. Select an option, or to understand and use the content on this page. Make sure you're familiar with the following topics. Installing Unreal Engine, creating a new project. Select an option to not drop down to see the content relevant to it. Quick Start Guide shows you how to add assets to your Unreal Engine 5 games. By the end of this guide, you'll know how to use the project browser to create new projects and navigate the content browser to find and add content. You'll also know where to find information on the FBX content pipeline while learning how to use the material editor to modify materials before applying them to a static mesh actor. Required project setup. Open Unreal Engine from the launcher. Create a new project using the game's blank template using the following settings. C++ enabled with starter content enabled. You'll need to enter a project name, so use ArtQuickStart. You now click Create Project and get started. The Unreal Editor now opens your new project. Visual Studio also opens and loads the solution file your project created. Creating folders is always good practice. Try to keep your project's content organized. The first thing you're going to learn is how to create a folder that will store your imported content. Before you get started, download QuickStart assets from the following link. Extract the downloaded asset to a location on your computer. From the content browser, inside the editor, click the Add New button. Click New Folder to create a new folder. Name the folder Quick Start Content. Double click the Quick Start Content folder. Naming conventions matter. Be consistent with naming folders and files. Importing meshes. There are a few ways to add content to your Unreal Engine 5 project. However, we'll focus on the content browser import functionality. Now that you're inside the Quick Start content folder. Click the Content Browser's Import button to open the File dialog box. Locate the Select the Basic Asset 1 and Basic Asset 2. FBX mesh files. Image what's this? Click Open to begin importing the FBX mesh files to your project. Inside the editor, the FBX import options dialog box appears. Clicking Import or Import All adds your meshes to the project. That's a lot of stuff. Click Save All. Save your imported meshes.
Wow!
Save Content dialog box appears. Click Save selected to save your imported assets. Navigate to the QuickStart content folder, then verify Unreal Engine 5 created the corresponding .ua asset files. Organize your assets so that you can easily find them. Importing textures. Navigate to the QuickStart content folder in the Unreal editor, then click the Content Browser's Import button to open the File dialog box. Locate the select the T-Rock 04D and T-Rock 04N Targa TGA image files. Click Open to begin importing the TGA image files to your project. A confirmation box appears in the lower right corner of the Unreal editor. Texture T-Rock 04N was imported as a normal map. OK. Click OK to accept the T-Rock 04N TGA normal map settings. Click Save All. Save your imported images to a Save Content dialog box appears. Click Save selected to save your imported assets. Navigate to the QuickStart content folder and then verify UE5 created the corresponding asset files. FAM, also accessible from the Epic Launcher, is a great place to find and share content. FAM meshes for import. If you have your own meshes to import, this section is for you. The UE5 import pipeline uses FBX 2018. Using a different version compatibilities. This image to be exported in the viewport. In the File menu, choose Export Selection or Export All if you want to export everything to the scene regardless of selection. In the Export dialog box, choose the content folder inside your UE5 project, enter a name for this file, and set it to FBX Export. Set your export options, click Export All. The settings in the geometry category above are the most basic requirements for exporting static meshes to Unreal Engine 5. You can use the default options for importing. Refer to FBX Import Options reference for more information on each option. Your asset has now been imported and you can drag and drop it from the content browser into your level. The example above, as part of the import options, we imported materials and textures. Well done, you've learned how to prepare meshes for import into Unreal Engine 5. If you want to learn more about the FBX content pipeline, clean modeling improves the game's performance. Hell yeah, it does. Creating materials. Materials are assets applied to meshes, contributing to a scene's visual aesthetic. There are a few ways to create and edit materials for your Unreal Engine 5 project. However, we'll focus on using the material editor. Navigate into your content browser. Click Add New and select Material. Okay. Name your material Rock. Your rock material is now ready to be used. Double-clicking the rock material, open the material editor. Read the material how-to documentation if you want to learn more about working with material nodes. Size your textures using powers of 2. Editing materials. At this point, you should have created a new material and opened the material editor. You can define a material's color, shininess, transparency, and much more in the material editor. You're now ready to edit the rock material you created. Select the main material node in the center of the material graph. The material editor will highlight the node for you when you select it. It is the only node in the graph named after your material. Inside the Details panel, change the shading model and default lit to subsurface. Your subsurface shading model enables 2 more pins in the main material node, opacity and subsurface color. Get your textures into the graph. Hold the T key and left-click inside the editor's graph area. The texture sample node should appear inside the graph. You'll want at least 2 textures. Repeat step 4 until your graph looks like the image below. Select one of the texture sample nodes and locate the Details panel under Material Expression Texture Base category. Enter the texture property, left-click the pull-down menu labeled None and select the color texture named TROC04D. You can also use the search field to locate the texture asset by entering TROC04D in the search field. Repeat step 6 for the other texture and sample node. Make sure you select Nomad named TROC04N. Whoa. Normal maps are cool. The material graph should resemble the image pictured above. Connect TROC04D texture samples color pin white to the rock material's base color pin. The newly connected white pin contains textures color channels. Connect the TROC04N texture samples normal pin white to the rock material's normal pin. The newly connected white pin contains information for the texture's normal map. The preview should look similar to the image pictured below. Hold the 1 key and left-click on the graph panel to create 3 constant nodes. The constant node is a modifiable scalar float variable. Hold the 3 key and left-click in the graph panel to create 1 constant 3 vector. Constant 3 vector node is a modifiable vector corresponding to color without an alpha channel. Read our constant expression documentation if you want to learn more about working with constant expressions. Your node should be arranged so that connections can easily be made without wires crossing or sliding beneath each other. Connect all of the constant 3 vector nodes to corresponding pins in the rock material main node. Change the values of each constant and material 3 vector by updating the value parameter in the Details panel. Specular value 0, roughness value 0.8, opacity value 0.95, subsurface color red 1. Preview should look similar to the image pictured below. Make sure you save your material before exiting the material editor. You're almost done. You've just used Material Editor to edit your rock material. A list of all Material Editor keyboard shortcuts can be found by going to Edit menu, Editor Preferences, Keyboard Shortcuts, Material Editor, and Material Editor Spawn Nodes categories. Applying materials to static mesh actors. You're now ready to bring things together. I also just put in another hour of reading. I don't damn. Oh, what's that one? Ha! Take that. Lethargy. First fucking hour of the week. Oh no, I swore. Take a drink. Cherry Cola Celsius. Applying materials to static mesh actors. You're now ready to bring things together. The objective of this step is to apply a material to the static mesh we imported. Specifically, you'll learn how to set an actor's default material, change materials used by an actor, setting an actor's default material. This section will show you how to set a static mesh actor's default material. The default material will be used whenever an actor is placed in the level. Inside the content browser, double click, boom. The asset you imported earlier in this guide. The static mesh editor will load your asset for editing. Inside the details panel, under LOD 0, left click the materials drop down menu. Select the rock material you created earlier. Materials should be available in the selection window. Your preview pane will update to reflect the newly applied material. Clicking the Save button first, close the material editor. Inside the content browser, drag and drop newly textured static mesh actor into your level. The specified material will be used anytime you place this asset in the level. Changing material used by an actor. When we place a static mesh object in our level, we create an instance of our object, an actor. For every instance of that actor, we're able to specify its material. Here's how you change a static mesh actor's material. Select your static mesh actor. Inside the Details panel, locate the Materials section and click the Materials drop-down menu. Inside the pop-up menu, select a different material. Actively drag and drop a new material onto the static mesh actor. You've just applied materials to your static mesh actors by setting your actor's default material, changing the material used by your actor. We've now reached the end of the Artist Quick Start guide. By now, you should have the skills needed to set up a project, create materials, edit materials, apply materials to a static mesh actor. Are you ready to do some exercises on your own? On your own, using what you know, create new material similar to this graph. In the main material node settings, simulate as plastic material, basic asset to the level, apply material to it, and update materials to apply a brick normal map texture. For more information on different types of content, refer to information on FBX pipeline in general, FBX pipeline content pipeline, information on FBX skeleton mesh pipeline, FBX skeleton mesh pipeline, information on FBX animation pipeline, FBX animation pipeline, information on FBX morph target pipeline, FBX morph target pipeline, information on FBX material pipeline, FBX material pipeline, information on importing audio files. For specifics covered in this quick start guide, refer to information on stored images, image types, texture import guide. Information on materials, information on content browser, information on static mesh editors. static mesh editor UI. Alright, so this time, yeah, like that. But then again, there's really 12 art videos on YouTube. I spend all my time fucking around. I won't get nowhere. There we go. Take a drink. AFBX content pipeline. Information on using the FBX content pipeline for meshes. Yeah, this should really be a fine. Goodbye.